Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Zulkifli from Group 8, where our material is Archimedes, and I will explain two material. The first one is the sunrise corner. So, in here, the goal is to figure out the upper bound for the number of grains of sand that could fit into the universe. Let's begin with the sunrise corner history. First, Aristarchus was the first documented to propose the idea of heliocentrism. So, what is heliocentrism? So, the idea that the Earth and the other planets revolve around the Sun, where the Sun is the center of the universe. But Archimedes, like the other mathematicians at that time, still believed in geocentrism, where the Earth is the center of the universe. In the sunrise corner, Archimedes is writing to King Gelon, in which he pleads for him to accept the idea of heliocentrism for his argument. So Archimedes will prove it in two ways: by his belief in geocentrism and in Aristarchus' belief, because Aristarchus is one of believable mathematician in that era. So the idea behind the pitch is to prove that there there does exist a number of grains of sand that could fit into the universe. In other words, his goal was to show that this number is not infinite. So jump to the question, but how large is the universe? So before find that goal, I think there are three questions should to answer that will lead us to that goal. The first is how large the universe on Archimedes. The second is how Archimedes calculate the amount of the grains of sand that can represent the universe. Third is how many grains of sand could fit into the universe. So jump to first question is how large the universe on Archimedes. For this first question, in here, Archimedes tried to describe it in a cosmos where he believed is same as universe. So uh, he said that universe is synonym with a cosmos, where cosmos is sphere, where the radius is the distance between the Earth and the Sun. That that his belief in geocentrism, where Aristarchus believed cosmos is like that, but the sun where the sun is the center of the cosmos and the radius is the distance to the earth that will bounded it around to make cosmos. So whether Archimedes or Aristarchus show us that the size of cosmos that their mean is equal. And then he began his argument to find the large of cosmos by stating for assumption critical for his proof. The first assumption is he said the circumference of Earth uh, is less than uh, 3 million stadia, or in our language we said it stadion, where one stadion is equal to 185 meters. So Archimedes said that the circumference of Earth is less than or equal to 3 million stadia, or equal to 555 million meters, where present estimate is equal to 40 million and 75,000 meters. Uh, and here where Aristotle have tried to uh, by show us 400,000 stadia or equal to 74 million meter. So the Archimedes show us is near to the present estimate neither Aristotle. And the second assumption is is he say the diameter of moon is less than to the diameter of earth and less than to the diameter of sun. In this assumption, Archimedes says, I follow most of the earlier astronomers. We think we know is true, right? And the assumption is the diameter of sun is less than and equal to the 3 times of the diameter of the moon. Where now we know the diameter of suns is equal to 1 billion and 300,000 and 1 million and 390,000 kilometers, and the diameter of moon is 3,474 kilometers. So at the present we know that diameter of sun is greater than four times the diameter of moon. You may think is not make a sense maybe, but this assumption is the good one because the other people like Archimedes' fathers, Hippias, give us 12 times, uh, where Aristarchus is give us 18 to 20 times, and we can see Archimedes do the better one by said is maybe equal 30 times the diameter of moon. But let's see the final calculation. So the last assumption, he said that diameter of sun is greater than site of Ciliagon inscribed in Cosmos. So what is Ciliagon? Ciliagon is a regular 1000-sided polygon. So if you write regular n-sided polygon for the smaller one, as the example we try with 3 for until 6, we can see the more side of the polygon, the closer to the circle shape. If we try to make it, if we try to make it, if uh, 1000 sided, it will look like this picture. We can see the shapes is going to closer to the circle shape. So the last for the first question is we will show the proof diameter of cosmos is less than to 10 billion stadia. So let dx is equal to the diameter of x, and px equal to perimeter of x, and rx is equal to radius of x. uh, uh, and this table will show us uh, so we will prove the diameter of cosmos is less than to 10 billion stadia by use this table contain the statement and reason that will conclude the proof. So the first statement is the diameter of Sun is less than and or equal to 3 times to the diameter of the Moon. The reason is because this is the assumption 3, and the second statement is the diameter of Moon is less than to the diameter of the Earth is because the assumption 2, and statement 3 is the diameter of Sun is less than to 3 times of the diameter of the Earth is because the lines 1 and 2, right? And the fourth statement is the diameter of Sun is greater than a side of 1000 polygon is because as assumption 4, and the fifth statement, the perimeter of 1000 polygon is less than 1000 times of the diameter of Sun is because the line 4, and then the sixth statement is the perimeter of 1000 polygon is less than to 30,000 times of the diameter of Earth is because the conclusion of lines 3, where the diameter of Sun is less than to 30 times of diameter of the Earth, and the fifth statement. So and then we found here the seventh statement is 3 times of diameter of cosmos is less than to perimeter of 1000 polygon. This is the theorem. Then the eighth statement is the diameter of cosmos is less than 10,000 times of the diameter of the Earth because the reason is because the conclusion of lines 6 and 7. The ninth statement is the perimeter of Earth is less than or equal to 3 million stadia is because the first assumption that I have explained, and the third statement is perimeter of Earth is less than or equal to the 3 times of diameter of Earth because the reason we know the the P is greater than 3 because the area of circle we know is P times the diameter, and we know the perimeter of circles we can find with the formula is P times the diameter, and we know that in here we multiply it by 3 of the diameter of the Earth, and then we know that if we times with 3 it will still less than to the 3 times of the diameter. And the 11th statement is the diameter of Earth is greater than 1 million stadia is because the conclusion of lines 9 and 10 we divided it by 3, then we get it. And the last statement is the diameter of cosmos is less than to 10 billion stadia is because the line 8 and 11. So the final conclusion we get that 10 billion stadia is near equal to 1 billion and 80 and 50 million kilometers. And now distance sun to Earth is near equal to 150 million kilometers, where the true diameter of cosmos, if we use the Archimedes way, is equal near equal to 300 million kilometers. So Archimedes' assumption that then get the diameter of the cosmos is greater than 6 times what the present known as the true diameter of cosmos. So with that assumption we get the 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 fall what the Archimedes finds in describe the universe a large with 10 billion stadia. So the second question is how Archimedes calculate the amount of the grains of sand that can represent the universe. So he describes it by associating it with the size of a poppy seed and a finger breadth. So first, it was what is poppy seed? Is the fruit is the seed from the fruit from opium tree, but it's not danger like in our mind because it just the seed were much have used in making cake, not as dangerous as narcotics. That the size is around 0.5 millimeters. So Archimedes described as one poppy seed is less than or equal to 10,000 grains of sand, and then uh, say that one finger breadth will contain less than or equal to 40 times the diameter of poppy seed if made in one line. And then as conclusion, a sphere with performed by that formed by the diameter with a finger breadth uh, will get less than to 64,000 poppy seed if we use with find it with use a formula of to find the ball to find the formula of sphere with the diameter is the finger breadth, and then we get the Archimedes get the on that there will be less than or equal to 640 million grains of sand. Next, the last question is how many grains of sand could fit into the universe? So this table shows us about how much grains of sand that will contain uh, in the sphere perimeter shown in the first row of the table. So if the sphere made with the diameter with one finger breadth, it will contains less than 6.5 times times 10 to the power of 8, or we can write is less than to 10 to the power of 9 grains of sand. If this pair formed by formed by 100 finger breadths, it will show us less than to 10 to the power of 15 grains of sand. And if if it 10,000 finger breadth, it will show out as it will need less than 10 to the power of 21 grains of sand. And we have known that one stadium is less than to 100 finger breadth. So uh, if we use change the change the So if we change the units with stadia, so 100 stadia will contain less than of 10 to the power of 27 gram of sense, and we will do it until we get the 10 billion stadia. It will contains less than to 10 to the power of 51 grams of sand. So we have shown that the diameter of cosmos is less than to 10 billion stadia, and we have find the grains of sand will contain if the sphere met with 10 billion stadia. So the conclusion is uh, the cosmos contains the cosmos with 10 billion stadia diameters will contains 10 to the power of 51 grains of sand. But by Archimedes method, if we Archimedes do it in this in Archimedes method, it it will show that the universe can hold up to 10 to the power of 63 grains of sand. So Archimedes concluded the discussion with the following words: these things will appear incredible to the numerous persons who have not studied mathematics, but to those who are conversant therewith and have given thought to the distance and the size of the earth, the sun, and the moon, and of the whole universe, the proof will carry conviction. What I want to say here, the important things is not just to show what Archimedes tried to find the correct conclusion to find how much the grains of essence could the grains of sense could fit in the universe, because we can see which times this era where Archimedes do it, and see see his time is different as now, and the different believable in show the universe is different as now, as present as as a present. But things the other important things is Archimedes prove us that there there will be a finite number can describe it what people think is impossible. And then the second material I will explain about Apollonius of Perga, the Conics. So the last of the three great geometers who arise in the period of 300 to 200 before Christ was Apollonius, a younger contemporary of Archimedes. Apollonius was born in the Greek city of Perga, close to the southeast coast of Asia Minor. As youth, he went to Alexandria, perhaps to study at the museum with the successors to Euclid, and resided there for many years to lecture and compose the first draft of his famous Conics. Later, Apollonius moved to Pergamum, which had a newly founded university and library modeled after those in Alexandria. While there, he became acquainted with the geometer Eudemus of Rhegamum, to whom he subsequently dedicated the first three books of the Conics. So, what Apollonius' work is, Apollonius wrote 11 works, and only two of which have survived, uh, including the Conics, and it is particularly renowned for his Conics, uh, where the Conics contains a world of 389 prepositions organized into 8 books, where 4 books have come down to us in the original Greek language and 3 books in Arabic translation, and one last book is lost. The initial 4 books of the Conics make up a systematic exposition and improvement of much that was previously set forth, with the remaining books devoted to original material. Apollonius' statement of the theory of conics was so admired that it was he, rather than Euclid, who in antiquity earned the title the Great Geometer. So that the reason what makes the Apollonius names is rise. So next we will talk about what the conics itself. Before that, the 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 discovery of conics section started approximately 2000 years ago. Over these years, many people have contributed to the idea, and many documents exist which support this study. So Apollonius just developed uh, the existing one, did it uh, but he did it so well and clearly that he was accepted by these conics. And then, uh, what is conics itself? In the conic section, the circle, like this picture, the circles, ellipse, parabola, hyperbola can be defined as the four curves that are obtained by intersecting a right circular cone and a plane. So in this picture, uh, we can we can now in general what is contained in the conics. So in the conics explains how to get circle, ellipse, and parabola and hyperbola. And uh, we will explain. I will explain the another achievement of Apollonius. So uh, Apollonius Apollonius known as uh, expert in optics and astronomy. Then planet theory worked on planetary motion, and then earned the nickname of of epsilon, because the one Greek letter that he get is shaped like the crescent of the moon, to which he devoted considerable study. And then in another he examines the distance of the Earth and Moon around 600,000 mil, but the argument seems unlikely, as it is some 2.5 times too great to great that what we now know what we now know. The last I will explain the lost treatise of tangencies. So in here, Apollonius actually is often remembered for a celebrated geometrical problem that he posed in his lost treatise on tangencies, Now today is the problem of Apollonius. It says, given three circles, construct a fourth cycle that is tangent to each of the given ones. And when Francis Vieta reconstructed the contents of on tangencies in 19th century, the circles problem became a focus of activity for many of the outstanding mathematicians of the 17th century. So uh, this is from me. Uh, Thanks for your attention. If you have a question, feel free to ask. Thank you. Assalamualaikum warahmatullahi wabarakatuh.